Okay, there we go. All right. Here we go. Okay. So here we're going to calculate some probabilities. Okay. So let's now make a we're going to make a 4-digit password, let's say. Okay. Now, for each digit, we can use any. So we're going to be using the 10 numbers here, 0, 1, 2, up to including 9. Okay? So imagine we're making such a password, okay? And then imagine we're going to select one at random. We want the probability of choosing a password with no repeated digits. Well, the first thing we have to wonder is, how many possible passwords are there? Well, if you have a 4-digit, yeah, maybe this will help. Let me try this. If you have a 4-digit password, right? The first digit, okay, there's no restriction yet, right? We're looking for all possible passwords, okay? Because we're looking for our sample space. Well, for the first digit, you have 10 choices, right? So we have 10 choices. How many choices do we have for the second? Well, since there's no restriction yet, because we're looking for the sample space, right? There's 10 choices. This could be different than the first number. That's possible. What we're saying now is it doesn't have to be. Same thing for the third digit. Same thing for the fourth. So the total number of these 4-digit passwords is 10 times 10 times 10 times 10. We're multiplying, right? And we get 10 to the fourth. That's how many passwords there are all together. That's our sample space. But we're only interested in how many passwords are there with no repetition. And that's exactly what this number is. P of 10, 4. Okay, that's what the permutations are. Remember, the order does matter here. Okay? The order matters. So if I interchange any 2 digits, you will get another password, for instance. So P of 10, 4, these are all the passwords that have no repetition. Order still matters, but now we're taking away repetition. That's what this is. And that's what this number is. So here, what I'm doing is, this is our n. N is how many possibilities there are. N is 10, right? Because we're making a password with 10 possible digits. The password's 4 units long, so we're arranging 4 of these digits to make a password. R is 4. So we have P of n r, and we have this. So these are all the 4-digit passwords where each digit can be any one of these that have no repetition. So the probability is 5,040 divided by 10,000. These are the outcomes, or the passwords in this case, we're interested in. So we divide that by the total number. The event here would be that we choose a password that has no repetition. In other words, we choose one of these. We choose a password from among these 5,040. So these are the outcomes corresponding to our event. This is the total number of outcomes altogether. So that's what we get here. All we're doing again is just dividing. Okay, let me do the next one with you guys. I originally had you guys trying it out. Not to say you're not capable, but I think for time consideration, let me do it with you. This one's actually very similar, except we're making a password that's 6 characters long. And instead of digits, each character is a letter of the alphabet. So each character is a letter of the alphabet. And we're going to select the password, okay? So the question is, what's the probability of choosing a password with no repetition? Well, again, the sample space is all possible 6-character passwords. All possible passwords. How many are there? Well, for each character, there are 26 possibilities, right? Hold on. Here we go. There are so we have a 6 unit long password. For each one of these, there are 26 possible entries, any letter through the alphabet. So that's for the first one. For the next one, the sample space, that is, looking for all possible outcomes, so there's no restriction at all, except in any password, order is what matters. So there are 26 possibilities for each. So we have 26 to the 6 possible passwords. Now, how many of these have no repetition? In other words, how many of these are permutations? That's what this comes into play. So our n is our 26. R, we're arranging 6 of those characters. So we have R is 6. So P of 26, 6, we get this by the formula, which is n factorial over n minus r factorial. And that turns out to be this. And so the probability then, this is the sample space, all passwords. These are the ones we're interested in. So we divide and we get this. Okay, I think we're going to stop here. Are there any questions on this? So I guess we'll have to stop here. I was going to show you, but I can always show you next time if necessary. But in Desmos, the calculator there, I think you have to press like the function key, and then one of the choices is NPR, which is the same as this. So if you need help, don't be afraid to contact me. I'm going to have office hours today as well.